There are lots and lots of other factorisation techniques, but the only other one we're going to look at this stage is how can we factorise a quadratic trinomial. That sounds pretty impressive, but a quadratic trinomial is essentially something that looks like that. ax squared plus bx plus c, where a, b and c are numbers, and a is not equal to naught. So the idea, the quadratic bit means the largest power is 2. The trinomial bit means there's 3 terms, potentially. If b is 0 or c is 0, we only end up with 2 terms, but essentially we're thinking of it as ax squared plus bx plus c, with one of those being 0, other than the first one. If a was 0, the thing wouldn't be quadratic. It would be linear, we would say. But we're going to come back and talk about that a little bit later on. Okay, so think of that as being our quadratic trinomial. We're going to try and factorise that. And I said there's a number of methods. The first method is just to try and guess. But we'll just skip over that and try and be a little bit more systematic. So we'll go to method 2. And what we're going to do is we're going to say, look, if I multiply out the brackets in x plus alpha times x plus beta, if you multiply out the brackets and collect the like terms, you get x squared plus alpha plus beta x plus alpha times beta. Okay, that's just using our expanding the brackets. So we want to keep that in mind because that's pretty important in there. And that now enables us to, with a little bit of educated guessing, to factorise a lot of quadratic trinomials. So let's go here with part A. Now, in this case, I want to write it like the left-hand side, so I want to find the right values for alpha and beta. So in here I'll say I want alpha and beta so that, now sitting in this quadratic trinomial here, I've got the coefficient of x as 6. So I want alpha plus beta to be 6. So that alpha plus beta is equal to 6. And I want alpha times beta to be 8. And alpha times beta to be 8. So I want two numbers that multiply to 8 and add to 6. Now, we could try and solve these simultaneously, but I think it's easier just to guess. I reckon, so I'll just say guess alpha is equal to 4 and beta is equal to 2. They multiply to 8 and add to 6. And hence, I can say, therefore, x squared plus 6x plus 8 must be x plus alpha times x plus beta. If alpha plus beta is 6 and alpha times beta is 8, then I factorise to x plus alpha, x plus beta. And of course you can always check your answer by multiplying out. And I'd go x squared plus 2x plus 4x, which is 6x, plus 4 times 2, which is 8. And so lo and behold, there's my factorisation. So in here, we've just made an intelligent guess on what they should be. Let's try B. In this case, alpha plus beta has to be minus 7 and alpha times beta has to be minus 8. So here, alpha plus beta has to be minus 7. Alpha times beta has to be minus 8. Now, once again, we could try and guess, but we can be a little bit clever in that if I multiply two numbers and get a negative number, that says they're of opposite sign. So alpha and beta, are of opposite sign. So one's going to be positive, one's going to be negative. Now, the fact that alpha plus beta is negative tells me that the larger of these two is going to be negative. Because if I add two numbers and the positive one's larger, then I'm going to end up with a positive number. So the negative number is larger in magnitude, I can say. Larger in magnitude. So I've got to have numbers that multiply to -8 and add to -7. So I think, therefore, I can guess that alpha is going to be -8 and beta is going to be 1. Multiply, -8 times 1 is -8. -8 plus 1 is -7. My other possibilities were, of course, I guess -4 and +2. That's the only other one that I could have even tried. So there's my alpha and beta. So I now have my factorisation. X squared minus 7x minus 8 is x minus 8, x plus 1. I'll expose that again in a minute, but let me just do C here for a bit. X squared minus 5x plus 4. Let me put this over this side so we can still see it. So, what I want is alpha plus beta to be -4, alpha times beta to be +4. -5, I should say, and +4. So, alpha plus beta is equal to -5. Alpha times beta is equal to +4. Now, alpha times beta is positive. That tells me alpha and beta, same sign. So, same sign. Either both positive or both negative. The fact that alpha plus beta is negative says they're both negative. In there. So I'm looking for two numbers, both negative, that multiply to +4 and add to -5. And so that tells me that I should be able to guess, I reckon, that alpha will be -4 and beta will be -1. Multiply to +4, add to -5. And there's my factorisation. So therefore that is x minus 4, x minus 1. Part D, here is 3x squared minus 3x minus 36. Now, our method over here had just 1x squared. So we're in a little bit of trouble, but we're happy because we notice that 3 is common to all the terms, so I can take it out as a common factor before I start. So that becomes 3 times x squared minus x minus 12. So in essence, I've actually factorised that already. That's written as a product of two factors. But I think we can factorise fully by factorising this quadratic trinomial as well. So in this trinomial, quadratic trinomial, I want alpha plus beta to be -1 and alpha times beta to be -12. What do these numbers here tell us? This is negative. Alpha times beta is negative. So alpha and beta are of opposite sign because I get a negative number. The fact that when I add them is negative, that says the larger of the two will be negative. The larger is negative, is what that tells me. So what factors have I got of 12? I've got 12 and 1, 6 and 2, 4 and 3. And I want a difference of 1. So this would tell to me here, so I'm going to guess alpha is equal to minus 4 and beta is equal to plus 3. They multiply to minus 12 and they add to minus 1. And I just went through and mentally checked the factors of 12 to work out what the possibilities were there. And so in here I have 3x squared minus 3x minus 36 is 3 lots of, and this becomes x minus 4, x plus 3. And of course, you get better at these with practice. Now, there are a couple of other methods suggested in your notes, so let me go through those. And this method, method 3 in the notes, says, look, what happens if you happen to have something other than just 1 times x squared? What if you've got ax squared in there? What do you do? Now, in this case over here, we were lucky because 3 happened to be common right across. But quite often it's not. And so, in here, here's an example, 6x squared plus 7x plus 2. You can see that we don't have a common term there, and I don't have just 1x squared. So, in here, if I'm going to try and factorise this, according to method 3, it says do this. First of all, calculate a times c. So, in this case, calculate 6 times 2. So, here. A times c, in this case, is 6 times 2, that's equal to 12. So that's step 1. Step 2 says, find two numbers, again your alpha and your beta, such that. So we want alpha plus beta to be equal to b. So alpha plus beta is equal to b, so in this case it's equal to 7. And we want alpha times beta, this time not equal to c, but equal to a times c, here. So we want that equal to 12. So I want two numbers that add to 12, multiply to 12, and add to 7. And again, you can go mentally through the factors of 12, and I guess alpha equal to 4, beta equal to 3. Looks like it should work quite nicely. Multiply to 12, add to 7. Okay, that has got us through step 2. Step 3 says, now write your quadratic in this fashion. So here, I'll go through and do it. So therefore I've got 6x squared plus 7x plus 2. And it says write it as 6x squared, so you leave that the same. And then you write your 7x as 4x plus 3x. So you go plus 4x plus 3x plus 2. So we've made use of the alpha and the beta to split up the middle term in there of the 7x. So I split it up into 4x plus 3x. Now it says you should be able to use our technique from before of looking for common factors. So I'm going to look for a common factor in that term and in those two terms. So sitting in here, I can see in here I have 2x as a common factor, and this will give me 3x plus 2. And here I have 3x plus 2. And if we have chosen our alpha and beta correctly, you will always be able to do this. It will always come out with a common factor. And so now this becomes 3x plus 2, I've got to multiply by 2x to get the first term, and I have to multiply by 1 to get the second term. And there is my quadratic trinomial factorised.
If you had the alpha and beta 3 and 4, they could be interchanged.
That's correct, and it won't make any...
Yeah, in this case, but in other cases?
Won't make any difference. It'll always work.
Yeah.
Yes, if you swap them around, you'd end up with the 2x plus 1 being the common thing here.
Yeah.
Okay.
In this case, 4 could be like alpha or beta. You could swap
Yes,
them around.
that's right. And what will happen is, depending on which one you use, as to whether you get 3x plus 2 being the thing here, or 2x plus 1 in there.
Yeah.
Okay, it just swaps the order around, but you end up with the same answer. Okay, let's do B. So, in here we want alpha plus beta to be 19, and we want alpha times beta to be 10 times minus 15, so minus 150. That looks horrible. But let's see what we can do. Alpha and beta times it are negative, so they're of opposite sign. Opposite signs. The fact that alpha plus beta is positive tells me that the larger one is positive. The larger one is positive. So, let's start factorising 150. I could go 150 and minus 1. Right, but the difference, when I add those on, I'm not going to get 19. Right, then I could go 75 and 2. 75 and minus 2. But again, that's not very good because 75 and 2 are a long way apart. So in fact, I'm going to want numbers that are close, well, relatively close together. So I keep going through and trying all the factors of 150 that I can think of. As I said, 150 and 1, 75 and 2, 3 and 50, right? 4 doesn't go into it. 5 and what will it be? 30. 6 goes into that. 2, 25, isn't it? Right, and that actually turns out to be the one that I want. So in here, just by trial and error, or by guessing, in here I can see that alpha will have to be 25 and beta will have to be minus 6. Yes, it took me a while to get from there to there. But that's what we do. And so therefore, I guess I need to, it's not immediately obvious that that's going to work. So let me do it. And so therefore I have 10x squared plus 19x minus 15 is equal to 10x squared plus 25x minus 6x minus 15. I've split my 19 into the alpha and beta that I've determined. And then I'll look for a common factor here and here. So here I can see 5x, and this will be 2x plus 5. Here I'm going to see minus 3, and that will give me 2x plus 5. Minus 6x minus 15. Okay, so there's plenty of places where we can make mistakes in this one. But anyway, we persevere. 2x plus 5 is now common. So I have 2x plus 5, 5x minus 3. I suggest that what you need to do is you just work out each step as you go, okay? Don't look at the whole thing and say it looks horrible. Just say, yes, I can do each step, and just work your way through. me put that over there. And the notes have another thing they call method 4. And method 4 is exactly the same as method 3, except that it differs slightly in this last step here. So step 3 is the only thing that's different. And so let me do the same example that we had before in here. So this one, 6x squared plus 7x plus 2. So in A, we found alpha was equal to 4 and beta was equal to 3. Same steps as above. Same steps 1 and 2 as above. Here, we did it here. So we've got alpha equal to 4, beta equal to 3. So same steps. Now, what we do is we write 6x squared plus 7x plus 2 as, now it says ax plus alpha, so that's 6x plus 4, then ax plus beta, so that's 6x plus 3, and divide the whole lot by 6. And that's it, done. Sitting in here, however, I can see that there's a common factor of 2 here. So that's 2 lots of 3x plus 2. And sitting in here is a common factor of 3. So here I have 3 lots of 2x plus 1, all divided by 6. I multiply by 2 and 3, that's 6. 6 divided by 6, so that and that cancel. And I'm left with 3x plus 2, 2x plus 1, which is hopefully what we got over here. 3x plus 2, 2x plus 1. Which method's better? Don't know. I don't care. Just so long as you can do it. One of them will be fine. Again, if you think method 4 is the one you want to use, I'd be sticking this on my cheat sheet in here just to make sure that you remember, so that you don't make a mistake in there. Probably what would be even better on your cheat sheet, if you're worried about this, would be to actually put a whole example on there, wouldn't it? That way you'd have all the steps to follow. Not that I'm trying to tell you how to get through the exam. Okay. Let's have a look at part B. So this time I haven't done the steps before, so let's do step 1. So step 1 and 2. So it says I want alpha plus beta to be minus 26, and I want alpha times beta to be 48. A times C. 3 16s are 48. Now, once again, alpha times beta is positive, says that alpha and beta are of the same sign. The fact that alpha plus beta is negative says they are both negative. So I want two numbers that multiply to give 48 and add to give minus 26. Minus 24 and minus 2 look pretty obvious. So to me, I can guess, without even trying too hard, that alpha will be minus 24 and beta will be minus 2. And now using method 4, this becomes 16x squared minus 26x plus 3 becomes ax, 16x, plus alpha times 16x plus beta all over 16. In the first bracket, I can see that 8 is a common factor, and that will leave me 2x minus 3. In the second bracket, I can see 2 is a common factor, That leaves me with 8x minus 1, all on 16. 8 times 2 is 16, and so this becomes 2x minus 3, 8x minus 1, and there I have managed to factorise that quadratic trinomial. So there are a lot of steps in there. As I say, just systematically work your way through, you will get there. Okay, now this says, use all our algebraic skills to simplify this. And there's no actual quadratic trinomial in that, but that doesn't matter. We're just using all our abundant factorising skills. And in the numerator, I recognise that as a difference of two squares. So I'll write that as a minus b, a plus b. And in the denominator, sitting in here, actually is something we hadn't mentioned before. But back here I said, look, one of our factorising skills was to recognise the difference of two squares. Another of our factorising skills might be to recognise the square of a binomial. So I'll just say down here, recall that I don't want a plus b, I want a minus b, in this case all square. We wrote that out, we said before that we should recognise that perfect square, that square of a binomial, and you can see that's exactly that there. So I can actually write this as a minus b, a minus b. And now I have a minus b on the top, a minus b on the bottom, and so that simplifies to a plus b, a minus b.